Microphone check 1 2 1 2. It's your boy, the NetworkBruh, back with another live stream. Episode number 107. 107 live streams, man. That's crazy, man. I don't think I've ever done anything 107 times. Well, I don't know. Except for maybe go to school or consecutive days. I don't know. Working. Anywho, today's lab is multi-area OSPF. This is a packet tracer lab, so this should be a pretty simple lab. Although I kind of brought it, I did not go through this, so we're gonna be doing this together. What did I do here? I did pull it up just to take a look at the steps and stuff. Most of it seems pretty simple. We've been dealing mostly with single area OSPF. Now we're dealing with multi-area. They just had some questions, reflection questions towards the end there. Now, remember we talked about LSAs and stuff, right? Link state advertisements. Anytime that we designate a router, we have a router on the OSPF network, and we call that router the designated router. And he has the link state database, and within that link state database, it has like all the routes in the OSPF network and stuff like that, right? But everybody gets a copy of things that are in this link state database with what's called LSAs, or link state advertisements. All the link state advertisements is what help you build your link state database, right? So if you want a copy of this lab here so you can do it along with us, it should be in the description box of this video. You should be able to download it. Let me know. We got Dear Tech IT in the building. Bruh, hello. I guess I forgot to do my bruhs there, right? Nah, y'all know my phone's slow. It's kind of laggy and stuff, so I'm gonna give it a couple more minutes. Give it some minutes for some people to tune in. I see some people downloading it. That's what's up. Y'all let me know if y'all can open it and stuff like that. You should be able to open it up with Packet Tracer 7. What version am I running here? It's 7.3, 7.2. Let me see. I don't even know. 7.3 I'm running. So you should be able to run it with anything newer than that. What else we got here? Oh, lordy, Lord. Jesus, we got to get into security, y'all. In today's news, hospitals hamstrung by ransomware are turning away patients. The ransomware epidemic continues to grow. That is just crazy, man. Are y'all getting tired of me? Like, y'all know I read like the news headlines just while people are starting to tune in and, trying to trickle into the class late, stuff like that, right? So I said, in the meantime, I'll read y'all some news headlines and stuff, right? But most of the time, like almost, it seems like nine times out of 10, it has something to do with some kind of like breach, cyber security attack, or some kind of like vulnerability that was discovered, right? Dozens of hospitals and clinics in West Virginia and Ohio are canceling surgeries. Jesus Christ, man. That ain't no laughing matter. I'm sorry. And diverting ambulances following a ransomware attack that has knocked out staff access to IT systems across virtually all of their operations. I used to work for a managed services provider, and I don't want to say which one it was. And we also had one of our clients, which is a medical, they're in the medical field. I'm not going to say which one it is either, but they got hit by a ransomware attack too. And it's just like hospitals and anything that's like Department of Defense, anything that has to do with like high level security. Those are like prime targets for cybersecurity attacks, man. The facilities are owned by Memorial Health System, which represents 64 clinics, including hospitals in the Marietta, blah, 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 blah. Early on Sunday, the chain experienced a ransomware attack that hampered the 3 hospitals' ability to operate normally. That's just crazy. Beginning on midnight on Sunday, the 3 hospitals started diverting emergency patients to Camden Clark Medical Center. The facility is an hour's drive. Whew. Imagine having to turn away a patient, man. They coming to get some surgery and they got or like coming to the emergency room or something like they're like, yo, you got to go to other hospitals like hour away because we got hit by ransomware, man. We got to get into security, y'all. We have to get into security because of things like this, man. Beginning at midnight, blah, blah, blah. I don't want to read the rest of this. Well, let me see. What else? Most of the Memorial Health System facilities have also canceled all non-urgent surgeries and radiology exams for Monday. For a month till today, really, and are advising patients who have an appointment with a surgeon or specialist on Monday to call ahead. We will continue to accept STEMI, stroke, and trauma patients at Marietta Hospital, officials said, and yeah, that's just crazy. They just go on and on. I'll give you a link to the description of the description, the article if y'all want to read it or whatever. But yeah, that's just crazy, man. We got Benjamin Masongo in the building. Appreciate you for tuning in. We got Kobe Lee. The fines must be outrageous, man. Tell me about it, man. That's just now. Granted, most of these hospitals and businesses they usually have like insurance that will cover like the costs and stuff like this, and like when a ransomware attack like this happens, right? Or they'll pay the ransom just to with that insurance money or whatever. But even if you pay the ransom, you're not guaranteed to get your data back, man. So that's just crazy. We got Coles Tech in the building. Appreciate you for tuning in. We got Zai in the building. Appreciate you for tuning in. But yeah, I was just reading an article on another ransomware attack in the hospital system, based out of where I said that was it South Carolina, West Virginia, and Ohio. Crazy, man. Crazy. That's just crazy, man. Anywho, y'all ready to get started? I hope y'all downloaded this lab or whatever. Should be real simple. Remember, we was doing mostly throughout the week, past couple weeks actually. I still wanted to stick with single area because I wanted to cover every little nook and cranny about single area OSPF. I was getting tired of it. I don't know about y'all, but anyway, when we deal with an OSPF network, we always start off with what? Area 0, which is known as the backbone area, right? And then you build on your network from there. Well, this network right here is called a multi-area OSPF network. Why is that? Because we have more than one area. We got area 0 right here in the middle. We got area 1 right here in the pink. And we got area 2 right here in the purple, I guess this is, or lavender. my daughter's favorite color there. Actually, her favorite color is now yellow. But anyway, and notice area 2 and area 1 all connect to the backbone, right? They all connect to the backbone, and that's how you design your network. You start off with area 0, and all the other networks go from there. Now, if we had another area right here, that's not going to be connected to area 0, right? Now, there is a way we can connect this, arbitrary area to this network over here. If y'all know what the answer is on how to do that, put it in the chat over there. That's y'all pop quiz. How would we be able to put an area that is connected over here that is not directly connected to the backbone? How would we be able to connect that? Now, it is possible to do that, but that would be a poorly designed OSPF network. We want to have our areas all, like if we had our fake network right here or fake area right here, and that needs to connect to the to area 0. So all the other networks, OSPF networks, if the OSPF network just decides to grow a lot bigger, they need to connect to the backbone area like that. So another area here, et cetera, right? So let's go ahead and get started. Task 1 is just, I guess we got the addressing guide right here. All the IP addresses and stuff and the interfaces on the network. Heard about Ford. No, I don't know what happened. Let us know, Coles. I don't know what happened about Ford. Was it another cybersecurity attack? Because it seems like cybersecurity attacks it's been happening daily, man. Ransomware attacks is just a common theme here. Zaya said ABR, which stands for Area Border Router. Are you asking me about it? What about area border routers? We do have an area border router in this network, this OSPF network. Which, by the way, if you guys are just tuning in, you can download this lab in the description box of this video, so you can do it along with us and stuff. So that way, I'm just not they got hacked, like the actual Ford, like the automobile manufacturer. That's just crazy, man. Oh, Ford, yeah, like that don't even. Not that they don't. Yeah, they don't really surprise me, man. This is. Everything is getting hacked right now, man. And when you say hacked, what exactly happened? Was it a cybersecurity attack? Was it ransomware? What was it? What exactly happened? Let me try to keep this thing on the top here. I don't know if you guys know about that feature. You can click that top so that way it keeps this window at the top here. So we got 3 routers to deal with here. I think we're going to configure OSPF here, and here. Don't worry about these little areas right here. Can't install updates. Oh well, leave me alone because I'm streaming right now. We're going to configure OSPF version 2 in this activity, blah, blah, blah. The interfaces are already connected and configured with IPv4 addressing. Great, so we don't have to do that. Step 1 is to configure OSPF version 2 on router 1. So this guy right here with a process ID of 1 and a router ID of quad 1 or 1.1.1.1 if you want to be complete. So we need OSPF. That's interesting. We need to advertise OSPF out of this interface here. as well as, I guess, these two interfaces there. I don't know. I think we're going to just do these. I don't know. Because we do have another, we have some networks over here. What we could do, though, is advertise OSPF on all of these interfaces without putting specific network statements. Should we do that? Because they didn't say exactly how they want us to do that. Let's just put specific network statements. Let's just do that. If we're wrong, it's going to let us know, right? Well, it's not going to let us know. We'll just see that the completion thing is not going up. So let's go to router 1. They didn't say what process ID, did they? Router OSPF1. We'll go with 1, right? Yeah, they did say 1 right there. Network statement is going to be 192. So network 192.168.10.0. The subnet mask is /30, but we don't work with subnet masks with OSPF. We work with wildcard masks, right? So 0.0.0.3. And then the area for that interface, oh, we can't do that. That's why. Okay, so there's something else. Like we can't do the broad network statement because we have 2 separate areas, right? So that was a tricky one. Area 0 for that interface. And let's see. If we do have some, looks like we got 12% complete. So I guess we were correct there. So that should advertise that should put this interface right here in area 0. Right? So we're good so far. We need to put some network statements that will put these guys in OSPF. Now we can have one network statement that should catch both of these interfaces right here. These interfaces right here, right? So we should be able to do, I think 10.1.0.0/16 should do the trick, right? Y'all let me know if y'all got a better network statement. What is going on here? I still got like worse stuff going on, man. Which, by the way, y'all hit me with that like button, man. I appreciate y'all for tuning in and stuff. Silas said they probably still run Windows 98. I don't know, man. Ford, that's crazy, man. They got hacked, but yeah, I don't know. I'm pretty sure they've got something later than Windows 98. But I hear you, man. They must be running something old for them to get hacked. Or they just don't have a great network security team or security infrastructure. Who knows? Let's do another network statement to catch those two. I want to use 10.1.0.0, and then we don't care about the last 2 octets, right? So we're just gonna say 0.0, right? Specifically 10. Oh, I did that wrong. Yes, I did that correct. 10.1.00 and then 00.255.255, and we're gonna put those 2 interfaces in area 1, right? Because this interface is gonna be in area 0. Those 2 are obviously gonna be in area 1, right? Y'all, does that network statement look good, y'all? Y'all let me know if y'all got a better looking network statement. We will find out if we're right if this completion goes up, right? So press enter, pray to the network gods, and it looks like we got 31% complete. So good. I guess it like that one. Let's see what we got so far. Show IP OS. We don't have any neighbors yet because nobody else is. Oh, there he goes. We got 2 neighbors. I guess it will be on the 10 side. Let's see. Yeah, it should be on the 10 side. So looks like we got some OSPF neighbors on this side over here. I don't know what's in there because when you click it, bloop, it's locked. So what we could do is we do OSPF neighbors and find out their information, right? That's 10.1.2.2 and another one, a neighbor in there. So somewhere in there, we got some OSPF neighbors. That's why they put it in the cloud. But we can't see exactly what's in there. We can get some clues, though. Notice it says xstart. Those 2 guys out there are designated routers. We could also run that command again to see if we're full. Yes, now we're full. So now we're fully adjacent, right? That means we're fully adjacent with these 2 neighbors over here. We don't have any neighbors over here because I think we need to configure OSPF or router 2. Cole's Tech said the Ford Motors hack has been carried out on a subdomain that is running what seems to be an outdated version of what. Who the hell is their web developers, man? That's just crazy, man. WordPress? Seriously? For a large organization like Ford? You talking about the automobile maker, right? This is crazy, man. Foster said the router ID, man. I'm glad you reminded me about that, man. I'm glad you reminded me. Don't forget about the router ID, right? So right now, router 1, let's see what my router ID is. Show IP OSPF. That should be good enough, right? Is that going to give it to us? Yes. So now my router ID is 192.168.10.2. And Diane can tell y'all how we got that router ID, right, Diane? So show IP interface brief. Remember, we said we pick our router ID by giving it to the highest up loopback, but we don't have any loopbacks. So the next candidate would be the highest IP address of an up interface. So in this case, just by looking at this, we see this is the highest IP address. It is up. So that is why this became our router ID. But they said to change the router ID, right? Remember, they say right here, give it a router ID of quad 1. So 1.1.1.1, right? So let's go ahead and do that. We know how to do that, right? We go to global config mode. We say router OSPF1, and we say router ID 1.1.1.1. Press enter. And notice, same thing as single area OSPF. For this router ID to take effect, we need to clear the process or reboot the router. But I didn't save my work, so I'm not going to reboot the router. I'm going to go ahead and just clear the process, right? And we'll see, right? Do show IP OSPF. We'll just do that. And we'll see my ID is still that. So we'll go ahead and clear the process. Clear IP OSPF process. We say yes. And that's going to bring down the neighbors. Bring it right back up. Bring it right back up. What the hell? Oh, okay. And then they're coming back up now. Bounced that ass. We went down and came back up. So now we do a show IP OSPF, and then we'll see now my router ID is quad 1, right? So now let's move on to router 2. Do the same thing, right? I think that's what they want us to do. Let's see. Y'all make sure y'all subscribe to this channel if this is the first time y'all tuned in. It says here, advertise each directly connected network in OSPF version 2 on router 1, which we've already done. Let's see. On router 1, they want us to advertise. Yeah, we did that already. We advertised this network, that network, as well as that network. So we did step 1 and we did step 2. Now we're gonna move on to step 3, which is routers 2 and router 3. So we're gonna do the same thing, except on routers 2 and router 3. Right? Y'all with me so far? Anybody got questions or anything? Diane's laughing. Oh, yeah, I'm just messing with you. I'm not trying to like call you out or anything, but you know, that's how we remember things, right? And we're like, oh man, I remember the teacher was telling me how to do this or whatever. So we go to router 2, and I guess we're 35% complete, right? If y'all just walked in, you're a little behind, but it's all good. Just replay the stream. There's a link to this lab right here so y'all can do it with us and download it along. But if you're just walking in, you'll be kind of behind, so you'll have to replay the stream. Anyway, unless you can catch up. So router 2, we'll go on to router 2 and do the same exact thing, right? So we press enter. We go to user exec mode, and then global config mode. We say router OSPF1. Let's start off with the router ID this time so we don't forget. He's going to be 2.2.2.2, right? So 2.2.2.2. Oops, .2. Press enter. And then we want to advertise our networks, right? Because these two are not neighbors yet, right? So router 1 is advertising that network to him, or he's putting that interface in OSPF. And now we're going to do the same thing with router 2 and put this interface in OSPF by using the network statement similar to the one that we did on router 1, right? So we just say network 192.1. You know what? I'm not even. Somebody tell me the network statement that will make these two guys. That way I'm not just doing all the work. These two guys right here, a neighbor. How do I make router 2 become a neighbor with router 1? Somebody, you sir in the back that just walked in late. How do you do that? Router 2 and router 1. Boom, boom. Somebody give me a network statement, and then I'll move on. A network statement that's going to make router 2 become a neighbor with router 1. There's the address. There's the area. I'm not going to do a giveaway just yet. But if you're just tuned in, the good folks at Boson NetSim, I guess this will be an advertisement here, right? Intermission break. Boson NetSim or Boson, they gave me a free like a demonstration application or I guess demonstration of their they gave me a promotional copy to demonstrate on my channel, right? The Boson NetSim, they have the exam software. They have a simulator for the CCNP exam, an RC exam, the Encore exam, and all that, right? And from time to time, I will do some topics from each of those exams on this channel and stuff like that, right? They gave me a free copy of the whole suite. Now, I'm trying to get to about 5,000 subscribers. My goal was to do it by the end of the summer, but y'all ain't letting people know about this channel, right? So once I get to that, I'm going to give away a copy of that application. So make sure you're subscribed to this channel and stuff like that and let everybody know about it, right? Going to, the Cisco Learning Network, going to any other Discord servers, which, by the way, I also have a Discord server. Let me give y'all a link to that, right? Where we at? Bloop. Here is a copy of the invite of the Discord server, right? That's the invite to the Discord server. Make sure you're joined to that. That way, sometimes I'll like cancel a stream or I'll do an extra stream. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time and stuff, right? And then and I'll let you know on the Discord server if I do something extra or if I cancel or whatever. But seems like we got a lot of shy people in here. So the network statement we're going to use is similar to the other one that we did on router 1. So we just say network 192.168. What was it? Zaya looks like, let me see. I like that one. I don't like the 2 dots that you put between 168 and 10.0, but I see what you was going with. That's the exact network statement I was looking for. So I'm gonna look what you got there. 10.0. Yeah, that's good enough. And then 0.0.3 area 0. That looks good to me. And I'm up to 51%. So yes, shout out to Zaya for that one. So now I should see a syslog message to let me know I'm a neighbor with router 1 right about now. Pray to the network gods, and there we go, right there. Process ID 1, number, this is my neighbor, 1.1.1. Who's that? That is router 1, right? And then loading to full. Remember there's several, what do you call it? Neighbor states. There's definitely several states that OSPF goes through before it becomes neighbors with somebody else, right? And we go from loading to full. It's really down, all the way down, then full. But now we're neighbors. So these 2 guys become neighbors thanks to Zaya over there. Now we're going to make router 2 become neighbors with whoever the hell is in this cloud right here, right? The way we do that is by using the network statement that is right here. It looks like the answers are right the hell in front of us. That's another reason why I was like, somebody should know this one, right? So we just go put a network statement to advertise to put this interface in OSPF, right? So network 10.2. I think 1.0 should be good. I like that one. And then we'll go with 0.0.255 areola 0. Press enter. And if there's some OSPF neighbors in there, we should get another syslog message similar to this one right here, right? Tomorrow, I don't know what we're going to do. Maybe another OSPF lab. There it is right there. So we got another message. We became a neighbor with somebody in there that's got the router ID of 4.4.4.4, right? 4.4.4.4, yeah. So now we're going to put this interface, and we're up to 57% complete, right? So we're almost done here, right? We need to put this interface in OSPF. So it looks like we'll use a network statement that is that should reflect that network right there. So we'll just, same router process, right? We don't need to create another routing process. We just do the same one, right? So we just say network 192. What was it? 168.10.4. So 192.168.10. I guess that's a 10.4 network, right? Yeah, it should be the 10.4. That looks like the network addresses. So it's not interface addresses. We'll go with the wildcard mask of 0.0.3.3. And we say area 0. I'm getting alerts for everybody that's down. I need to turn them alerts off, man. Everybody's downloaded this lab. Like, somebody's downloading lab. But that's good, man. I'm glad you guys are doing this along with me. Area 0. So we're not going to get a neighbor yet. Why? Because we put this interface in OSPF to advertise out of that network. But this guy, I don't think, is an OSPF neighbor just yet. Right? We're at 63% complete. So we're almost done here, right? We'll probably do one more lab. It's a real easy one, too. So we need to do router 3. Make him become a neighbor. We'll put this interface to become a neighbor. And that's another thing, too. I make a mistake by saying that, and I hope you guys don't do the same thing as me. As a matter of fact, I was watching a INE video, and I can't remember his name, but he said the same thing too. We don't put routers in an OSPF area. We put their interfaces in an area, especially when it's a multi-area network, right? So, for example, router 2, although we have him sitting in this big-ass yellow blob right here, and we say he's in area 0, that's you can say that's an accurate statement, but we want to say his interfaces, this interface is in area 0, this interface is in area 0, and this interface is in area 0. The reason why I say that is because if you look at router 1, he sits in area 1 and area 0, right? Multi-area. That's why we call it multi-area. So he's sitting in 2 different areas. As who said that? Zaya said this guy would be considered an ABR. He's in an area border router because he borders 2 areas, right? He's sitting right in the Great Wall of China, sitting in a border between 2 areas, right? So, but we don't want to say he's in area 1 and area 0. He has an interface in area 0 and 2 interfaces in area 1, right? So make sure you get that in your head. Don't say this router is in that area. Say this interface is in that area, and these 2 interfaces or these interfaces are in that area when we're talking about multi-area, right? So let's go to router 3 and put that interface in area 0. I'm not going to say router 3 in area 0. I'm not going to say that, right? So we do that by saying, and it looks like we did that already. What am I thinking? We did it. All right, we did that. What I want to do is now is put these 2 interfaces in area 2, right? Got with me so far? Right? So make sure you get that in your head, right? I was watching a video this weekend, and I was like, yeah, you know what? I'd be finding myself saying that. Don't say that. It'll make it more confusing. So network 192.168. What network is that? This is the 2.0 network. This is the 1.0 network. So we don't want to be that specific. So we want to say 0.0 here, and a wildcard mask that's going to catch to match the first 2 octets, and we don't care about the last 2 octets, right? How do we do that? With 0.0.255.255, because we don't care about the last 2 octets, and we say those 2 going to be in area 1, right? Press enter, and if we got some neighbors in there, we should get a syslog message letting us know. Get on our knees, pray to the network gods, pray your hand emoji. It look like we got some troubleshooting to do here. 192.168.2.4 or 68.0.0. You know, OSPF is kind of slow sometimes. It don't like that. It looks like we need to come up with another network statement. Oh, you know what? Yeah, okay. I see what my mistake is already. I'm gonna leave this right here, and I'm gonna give y'all another quiz. Why did I get this? Why did I get this wrong? Why do we not have an OSPF neighbor? This is the last network statement I put in. It is wrong, and I don't have an OSPF neighbor. Why is that? Benjamin said you can activate the OSPF on the interface like IP OSPF process ID area blah 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 blah. That's right, Benjamin. That is another way we can put. That is called an interface specific OSPF configuration. So we can put a specific OSPF rather than working with all these network statements and making a fuck up like I just did right now. We could have done exactly what Benjamin did and just put an interface in OSPF to participate in the OSPF area by doing exactly what he just said. So like, let's just say we wanted to put that interface in a specific area. We just do IP OSPF and then the process ID in an area blah 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 blah. Anybody why I know we don't have an OSPF neighbor here yet? Should I do another intermission? I know there's a lag there, so that's why I can wait. Foster got it correct. Wrong area. I put the wrong area. So that's why I'm glad y'all paying attention, especially Diane over there. So I put the wrong area. So it is not area 0. I mean area 1, right? Area 1 is over here. I was so stuck in the pink area. Like my daughter over there, she just loves everything pink. Like her whole damn room is pink. So, and this is area 0. These 2 interfaces actually need to be in area 2. So that's right, Diane. We need to fix that. Before I don't even change this, right? Because then it'll stay there. Let's see what happens if I put area 0 also. Let's see what happens if I do that. Will it override the other one? Or will it just put both? Let's see. Change from area 1 to area 0. Let's see. We got an area change message. I've never seen that before. Let's see. Let's do a show run. Can we do pipes on this? No, you can't. Yes, you can. Good. OSPF. And let's see which area was the one we did not like. Yeah, okay. It got rid of the area 1. And I put it in the wrong area again. What the fuck? What's wrong with me? Area 0. All this shit I'm talking. router OSPF 1, and let's get rid of this, and it is area 2. That's what I meant to do. Now we changed it from area 0 to area 2. Now let's see here. Received invalid packet, mismatch area ID. Let's see here. Oh, I know what I did here. Let's see here. I know what I really messed this up. Okay, here's what we needed to do. 192.168. This needed to be in area 2. So we need to fix all of this. Let's get rid of this. No this. Boop. Notice we're coming back up. And let's take a look at those network statements again. Section OSPF. Y'all notice how I just filtered down to just the OSPF area? We needed a statement that's going to catch them two right there, 192.168. Oh, you know what? I'm in the wrong router. That is why. That's why. Boop. Boop. That's what I meant to do. I'm supposed to be a router 3. There we go. Enable. Show run. Did we put any statements in here? Section OSPF. Let's see. We didn't do anything over here. Okay. Okay, so let's do this. Go to global config mode. We need to put this interface in area 0, those two in area 2, right? Okay, so router OSPF 1. The wrong area. Yeah, Benjamin said I put the wrong area. I changed it there. I was supposed to do area 2, but I was also in the wrong router. So I get a lot of bruhs for that one. Network 192.168.10.4.000.3. We say area 0. Let's see. And then what is that going to bring up to? We are at 76% complete. So now we got a neighbor there. We have this guy became a neighbor. So now we need to put a network statement that's going to catch those two right there. And then theoretically, I should join neighbors, become neighbors with those two in there. So I was in the wrong router there. All that, y'all gotta understand, man, to be lecturing and try to do all of this at the same time, looking at chats and trying to remember all this stuff is kind of difficult, man. I'm not trying to make excuses here, but just give me some credit here. So network 192.168.0.0, and then we said 000.3, area 2, like Benjamin said. Press enter. Get on our knees, pray to the network gods. I hope that one works. No, not 0003. We needed to do 255. So let's get rid of that. I'm putting all these wrong statements here. What is wrong with me? All right, so 255.255. You know, still stuck at work. I don't know what's wrong with me, man. I don't know what's wrong with me today. I was ready to lab today, though, but I just wasn't. Okay, there we go. Now we got some neighbors. Good to go. Now we good. So we got a neighbor with a router ID of quad 7 and quad 6. So somewhere in there, we got some neighbors, and they became neighbors through these two interfaces right here. So we are now at 95% complete. So we got 5%. We need to do something. What are we missing? It says here they want us. Oh, we need to change the router ID for router 3. That's probably what we need to do right there. Router ID needs to be router 3.3.3.3. And I think that should bring it up to 100%. Let's see. Show IP. We'll verify that first, right? OSPF. And then we'll see that our router ID is 10.6, 192.168.10.6. We need to change that. So go to global config mode. We say router OSPF 1. We say router ID. He's supposed to be 3.3.3.3. Press enter. He's still not that yet. Until we clear the process, clear IP OSPF process. He says, do you want to reset all processes? We say yes, press enter. The process went from down. It should come back up in a second here. We should get some messages. Let's see where we at here. We're at 100% complete, so we're good to go so far. It already graded us, and we got 2 neighbors there, 2 more neighbors there. Should we come neighbors over here too? Did we get that message yet? There it is right there. There it is right there. That's what I like about packet trace. They really simulate how iOS works, man. They did a really good job. I gotta understand, packet tracer. Don't sleep on packet tracer, man. It came a long way. Back then, they didn't have like ASA firewalls. They didn't have there's a lot of stuff you couldn't do with BGP. Now you can do a lot of BGP stuff on here. I love packet tracing, man. So don't worry, we'll get back to EVE-NG and stuff like that and do more complex networks and stuff. Not these pre-made labs. I haven't done Freestyle Friday in a minute. Foster said router ID. Yep, I did that. So I think we're good to go. We're at 100% complete. We finished right at the half-hour mark. There is another lab. Well, I guess we'll take another intermission here. Oh, you know what? They have some reflection questions in here. They want us to use the following commands to gather information about our OSPF multi-area implementation. They want us to do show IP protocols and dissect that. So let's pick one router. Let's pick router 1 and do show IP protocols and see what that gives us. Information about the multi-areas, right? Show IP protocols. And it looks like, let's see here. Notice it says here, we are routing for 2 networks, area 0 and area 1, right? This is from router 1's vantage point, right? He is routing for area 0, which is over here. And he's also routing for area 1 through these 2 interfaces right there with these 2 respective network statements. Y'all see that? What else? And that was for process ID 1. That's our router ID. Number of areas in this router is 2, right? We haven't seen, most of the time we've seen 1 area because we was mostly, like last week, was doing mostly single area OSPF. So now we're seeing the 2 there. Getting a little happy there because we're working with multiple areas. We'll get more into stub networks and what they are and normal areas and stuff. Well, we can say this. A normal area would be just like a regular, like this would be a normal area. A router that has OSPF network in it, and this would be considered a normal area. It's not a stub. A stub is kind of like, it's like a dead end almost. That's why they even call it a stub, right? So, but we'll talk about that once we start talking about NSSAs and stubs and stuff like that. We'll break those down. Matter of fact, I got some videos that I did about years ago on my channel. If you look deep in my playlist, I think it's a CCNP playlist. I have like videos that talked about stub networks, and we did a lab, I think GNS3 Vault, and I broke down stub networks and stuff like that, right? What else they want us to see here? We have some routing information sources so we can learn OSPF networks, OSPF routes from these guys right here. 1.1.1, who's that? That's me. He is 2.2.2, so we have a source from there. 3.3.3, who is that? That is this guy right here. So we can learn OSPF networks or routes from these rest of these guys since we're neighbors with him and he's neighbors with him, etc., 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 right? That's why we have sources 4.4.4, even though 4.4.4 sits, I think, somewhere back here. Or maybe back here. I can't remember. But we're not directly connected to 4.4.4. However, he is a routing source, information source for us because he's in the OSPF network. Default administrative distance for OSPF is 110. What else can we say? They want us to look at some other show IP route. We know that when we run that command, that's our routing database. I mean, our routing table. And all the OSPF learned routes have O's beside them. If there is an OIA, that is not Orlando International Airport. I'm in Orlando, by the way. But this is actually intra-area routes. So routes that we learned from other routers. They're not external, but they're in an area. It's hard to explain that shit, man. An intra, I don't know if that's intra or inter. Let's see. OIA. If you look in the legend right here, OIA is... it's OSPF, and an IA would be inter area. Not to be confused with intra. And I don't see where intra area is. Where is it? I don't see intra area. Or is that only for... Yeah, GIP. Nonetheless, what else do they want us to look at? We did the routing, show IP route, show IP OSPF database. We did show IP as the OSPF database. Well, they want us to use these commands to answer these questions here. So if y'all want to help me along with these while I'm explaining these too, that's why I like labbing with y'all, because y'all kind of help me out. All I gotta do is look over in the chat, and y'all can tell me what I'm doing wrong here. Benjamin said international airport. Yeah, exactly. So Orlando, that's their international airport here. No, that's not what OIA stands for. It stands for, like I said, OSPF and intra area. It's an inter area route. Which routers are internal routers? So we look at this topology right here. We don't need to look at any commands or stuff like that, right? So the internal routers are routers that actually have all routes. We don't want to say a router in an area, right? Remember I said that, right? We want to say, we want to talk about the interfaces. So in this case, an internal router would be a router that sits that has all of its interface in one area. I think that would be the most accurate statement. So, for example, router 2, he has this interface, that interface, and that interface, all in area 1. So he would be considered an internal router. Which routers are backbone routers? Now, I believe routers are backbone routers if they connect to the backbone. What's the backbone known as? Area 0, right? So router 2 would be considered a backbone router because he sits in area 0, right? Now, router 1 and router 3, I can't remember if those would be considered backbone routers. However, they do connect to the backbone, right? Because they have an interface in area 1. He has interfaces in area 2, but he also has an interface that connects to the backbone. So does that mean he is also a backbone router? Anybody want to let me know? But I think it is. While y'all figure that out, I know this one right here for sure. Which routers are considered an area border router? Now, this is exactly what I was saying earlier. Type your answers here. I guess we're supposed to be able to type there, huh? Look at that. They did it in white text. The routers, the area border routers, if they sit on the border of an area, right? So in this case, or they have interfaces. We don't want to see how I said it again. Router 1, for example, would be considered an area border router because he borders 2 areas, right? So he sits between area 1 and he has an interface also in area 0. So he would be considered an ABR, as Zaya pointed out. Router 3 is also an ABR because he sits between, or she, if I want to be politically correct, router 3 has interfaces in area 2 and that one in area 0. So router 3, therefore, is considered an area border router. He sits between 2 areas, right? Or has interfaces in between 2 areas. Which routers are autonomous system routers? Now, this is a tricky one, right? A router that sits in an autonomous system, that will be considered an autonomous system when it sits, but when it has an interface in OSPF, but also has an interface in another routing protocol, like BGP, for example. So he has an interface in BGP and also has an interface in OSPF. So he'd be considered an ASBR or autonomous system. No, I'm sorry. Yeah, an autonomous system. I guess that would be boundary router. I think they meant to say autonomous system boundary router. I don't know. Y'all let me know. I think they meant to say ASBR. Like this right there. And why would this be an ASBR? Or why would there usually be an ASBR in this type of network? Or autonomous system routers. Which router? I don't think anything's an autonomous system router. Y'all let me know if they. I don't like that question right there. They said an ASR, basically. I've never heard of that. I think there's a typo there. Y'all let me know. Let me see. Let me look this up. I need to fact check myself here. ASBR. Let's see. Special areas. I'm looking up stuff on. So router types. Let's do this. I can look up OSPF router types. Francisco said border router as autonomous system border router. Yeah, that shit is tricky. Exactly. See, you hear me. You see what I'm saying, Francisco, right? He said autonomous system routers. I think they really meant to say autonomous system boundary router, or like what you said, autonomous system border router. You can say either or. But yeah, I think they meant they forgot something here. So which routers are generating type 1 LSAs? Type 1 LSAs are also known as router LSAs, right? He basically identifies himself with a router LSA. He lets everybody know, here's my router ID, and they do that through a type 1 LSA, right? Let's see here. Yeah, so each router within an area will flood a type 1 router LSA within the area. So this router would flood a type 1 LSA. Pretty much any router that's participating in OSPF will generate a type 1 LSA. He needs to let the people know about his router ID. He gonna do it through the type 1 LSA. So will router 3 and so will router 2, right? So we can verify that with this command right here, show IP OSP database. So let's pick one guy. Let's pick router 2. We haven't bothered router 2 in a minute. and we say show, can you do it? Show IP OSPF database. And usually the first type of LSA, the first LSA type 1 will be at the top right there. So this right here will be considered, he said router link LSA. Yeah, that will be the router LSA right there. So we have the advertising router. We have their information there. Now this right here will be considered the type 2 LSA, right? I think that's what they ask us next. Which routers are generating type 2 LSAs? Type 2 LSAs are each router within the area. I'm sorry, that's the wrong one. The network LSA, that's called a network LSA, or type 2 is created for each multi-access network. Remember the OSPF network types. There's broadcast and non-broadcast. See, I need a refresher on these. There's 11, believe it or not, there's 11 types of LSAs, right? OSPF LSAs. Now for the CCNP exam, you only need to know, I think there's like 5 of them you need to know. 1, 2, 3, 4, 5, and 7. I don't think you need to know about 6 and 4. Do you really need to know about 4s? I don't think so. Yeah, you need to know about 4. Summary ASBRs. They give you summary routes and stuff like that. Let's see here. Which routers are generating type 2 LSAs? So we said the network LSA. So let's see here. Router. Let's see. So yeah, so this will be the type 1 LSA right here. I believe that's type 2. Now this, I believe, is a, let's see. Summary netlink. I think that is the type summary type 3. I believe that's type 3. So 1, 2, what is these guys right here? That will be type 3. Type 3 for area 0. Type 3 for area 1. Router link would be, I think, type 1 as well, right? Is that what it says right there? Yeah. So this would be the type 1 for area 0. That's why I was getting confused, because they be spread out for different areas. See, now we're working with multi-area here, so it gets a little not really confusing. It's just I'm so used to doing single area OSPF. So this right here would be the type 1 for area 1. And that's how we learn. Let's see. Let's do this. So we learned about this LSA right here. It's a type 1 through 2.2.2. Who is that? We do show IP Ospf neighbor. We only got 2 neighbors. Oh, I'm on router 2. That's why. I'm on router 2. Which routers are generating type 3 LSAs? Type 3 would be considered a summary LSA. And hold on. Francisco said, I'm studying for my CCNA right now. Oh, it's all good, Francisco. That's what's up. Yeah, I haven't taken the CCNA since 2018 is when I got it. And then I think it lasts for like 3 years. And then after that, I think when COVID happened, well, I took subsequent exams after that. Like I took the route exam, took the switch exam, didn't have enough time to take T-shoot, so I don't have my CCP just yet. And then when COVID happened, they extended everybody's expiration date for like another, I think, 6 months or something like that, or maybe a year. I can't even remember. Benjamin said type 1 is generated with directly connected inside the area. Yes, exactly. So type 1 would be the ones that are directly connected to each other. So router 2 is flooding a type 1 to him. Router 3 is flooding a type 1 to him, etc. Vice versa. Type 2 is multi-access router DR, or designated router. Is that designated router you're trying to say there? But yeah, the type, like I said, there's 11 type LSAs. I haven't memorized them all. As y'all can see here, I need to get a refresher on all of these here. How many intra-area routes does each router have? We could do that by looking at the routing table, and like I said, the OIA will let you know which one is an inter-area route. So for example, we go to, let's do router 3. We haven't touched router 3 in a minute. We do router 3 and do a show IP route, And all the ones that say IA will be considered an inter-area route. So, for example, this is an OSPF route, but it's not inter-area. This is an OSPF route, but it is inter-area. What area is that? The 10120 network. Where is that at? 10120 will be right over there. So it's basically an area. It's almost like, let's see. Would I say that's a network that is like externally learned? Could you say that? I guess we could say that because this is not directly learned. Like I didn't learn it directly from my neighbor, right? So from router 3, I didn't learn it from my neighbor. I kind of learned it from him, but it really came from, it's a network that's out here. So router 3 has an inter-area route 2.0, which is this interface right here, that network right there, right? So that's how router 3 got it. And then the same thing with 10110, which is right over here. So that is also, I guess, considered an inter-area route. Why would there usually be an ASBR in this type of network? I don't even know how to answer that question, because do we have another autonomous system? Because like I said, an autonomous system would be an ASBR would be a router that sits between two different routing protocols. So if he's sitting in between EIG, has an interface between EIGRP, and he has an OSPF interface right over here, then I would be considered an ASBR. So unless anybody else want to chime in and answer that right there. But he said, why would there usually be an ASBR in this type of network? I guess because he's sitting in between two OSPF areas. So I don't know. But that's the last question there. Y'all want to do one more lab? Y'all let me know. That was pretty much it. If you want to copy this lab, just go in the description box below, and it's the first lab there. And you could just watch the replay if you just kind of like tuned in late. Make sure you subscribe to this channel. I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. And we're right at the hour there. We can do one more lab if y'all want to, though. Y'all let me know. While we figure that out, let's see what else is going on in the IT industry. That's crazy right there. That's crazy. Let's see what we got going on here. We'll give it a couple more minutes, and then if y'all let me know if y'all want to get started on another one. I guess we got time for another one. The other one is it's a real simple one. As a matter of fact, I think all the answers are on it already. So this is the greatest right here. Cisco and remote work lessons learned in education during the pandemic. Schools around the world, like most businesses, had to scramble to keep operations running smoothly during the pandemic. A recent Cisco event points to some universal lessons to keep in mind the next time this happens. I don't know about y'all, but I love working from home, man. Ever since, man, it's like, man, the pandemic has been a blessing and a curse because one, a lot of sick people around the world and stuff like that. A lot of people dying from COVID and stuff like that. And we have to protect ourselves. And obviously, it's a pandemic, right? And it's becoming now with the Delta variant. It's a lot more contagious and stuff like that. You got to get vaccinated and stuff. And even if you do get vaccinated, I don't know if y'all heard, but there was a Carnival cruise line, I think in like Galveston, Texas or whatever, that docked over there. And 99 or 95%, they had a high vaccination rate on that boat. But 27 people still got COVID-19, got infected. Some were asymptomatic, some were symptomatic, some were displaying symptoms, but they all had to stay in their rooms. Can you imagine going on a cruise and you had to stay your ass in the room? That's some shit, man. Like, I want my money back. But the blessing has been being able to work from home, man. I just love it. Like, now I'm working kind of a hybrid thing where I'm on site and stuff like that and working remote. But I just love working from home. Being able to, just make, saving money by not having to get stuck and trapped. Man, I just love it, man. I just love it. So, and let's see here. It just says one of my favorite things of briefing is when a vendor brings in customers who talk about how they did the impossible. While they do these to promote vendor wares, they also provide a wealth of knowledge, blah, blah, blah. They talk about everything but the damn why it's been great to work from home and remote work, work from home and stuff. Have vendor issues and hardware shortages. There wasn't much love for OEMs except for Cisco. According to Rico, most vendors laughed at what the school wanted to do and said it was trying to be an ISP. What the fuck does that have to do with this article? Is just all over the place, man. Whatever. I'll give y'all a link to that article if y'all want to read it. I was going to see what like this is all over the place. I don't know. Foster said autonomous system border router, ASBR, a router that is connected to one or more logical entities, AS, usually through an exterior routing protocol such as BGP. Exactly what I explained. Now, that's why I didn't understand this question, or why they maybe I'm not reading this right here, but what it says here, why would there usually be an ASBR in this type of network? Like you said, it should be neighboring another router that has another routing protocol, right? So we go to router 3, and let's just say, I don't know. Let's see what CDP neighbors we have next to us. We have 2 switches and router 2. I don't see any other routers in here, right? So apparently there's 2 switches in here. Maybe they're running, I guess these switches are running OSPF, because it said we have some neighbors in there. We do show IP OSPF neighbor, and it says I've got 3 neighbors there, right? How about we just do show IP protocols? Do we have any BGP neighbors or OSP or EIGRP neighbors? I don't see none on here. So I would think another, if I'm a router that is sitting in an OSPF area, and I have another interface in another routing protocol such as BGP or EIGRP, then I would be considered an ASBR, right? Kevin said, remember, usually default routes in OSPF get injected as external. Okay, so that's what is that what's going to answer that question? Is that what you're saying? And that's how come I would have be an ASBR? Default information originate is always effectively redistribution. So it makes those. Oh, gotcha. Light bulb moment. Y'all see that? That's likely what they mean there. Gotcha. Okay. So now I see what you're saying. I like that. See, this is why we fuck with you, Kevin. Now listen, this is what he meant here. So this router right here would probably be injecting a default route to these guys right here, or vice versa, right? So then he would be considered an ASBR, right? Because he probably has a BGP neighbor somewhere in here, as well as interfaces in OSPF. So yeah, that's probably, like you said, that's probably what you mean there. Francis said, toughest part for me is how do I tie what I'm studying to real world situations? I need to find more credible resources like blogs or LinkedIn pages. That's a good question, Francisco. One thing you could do is buy, let's say, a router or firewall, right? And just implement it in your home network, man. I learned this one from Network Chuck, who's a great YouTuber, by the way. I'm pretty sure y'all heard of him. If y'all heard of NetworkBruh, that's partially where I got my name from. But anyways, he said, I think it wasn't him. It might have been Keith Barker, or it might have been Keith Barker or Network Chuck. I don't remember. But anyways, use put a home router, a custom home router sitting next to your the router that the ISP gave you. Put the ISP modem in bypass mode, and then filter your network using the firewall and stuff like that. And if you got other home users, right? If you got say your wife or your kids or whatever, and you kind of configuring the router, and then all of a sudden, hey, why we can't stream anymore? Now you got to fix it. That is one real word. And then it's safe because you're dealing with your family and not necessarily some high-end stakeholders or CEOs at some huge company or whatever, right? So you're kind of manipulating routes and using firewall, access control lists and stuff like that. That's probably the best way to tie in what you're doing to the real world, is by doing the shit at home, having a home. Now, I personally keep my lab on the grid. My lab off the grid. I have a home rack and stuff like that in my room here, and I kind of play with it that way. I don't really like messing with my home router and doing all that stuff here. So, and plus, there's a lot of simulators like Packet Tracer, for example, that we're using right now, and also you know, even G and GNS3 and stuff like that. But that's probably the best way to tie in what you're studying to the real world. Just fuck with your family, man. What else? Yeah, I guess that's it for this lab. Let's do one more lab. It's an easy advanced lab one. So we finished this one, but I liked what Kelvin said there. That is one way, because if we have a router that's sitting on between two areas, he is most likely going to be doing default information originate, which is a way to propagate a default route, and he would be doing that with a router that's using another routing protocol, most likely. Do we want to save? No. So I'm gonna bring up. I was looking up some stuff here. Looking for a contractor, y'all. If y'all know anybody in the home building and trying to build a house and stuff like that, working on getting pre-approval and stuff like that. Francisco said, "Good idea." Yeah, man, that's probably the best thing to do, man. You know, your kids are gonna be like, "Why did somebody shut off?" And then you just kind of like mess with them, like shut off one or two users, create an access control list for just your wife or whatever. Be like, "Oh, you want to mess with me?" You know, just bloop, shut her off. You know, Instagram, you learn how to filter websites and stuff like that. That's probably the best thing to do, and it's the safest way to do it. And you know, if all else fails, you're like, "All right, let me just bypass my router for now, just to get everybody online for now." You know what I mean? What was I going to do here? Oh, yeah, we was going to open up one more lab. This should be a quick lab. Y'all give me a second here. It should be, if you look on the description of this video, it's another packet tracer lab. It's OSPF advanced features. They ain't really advanced. We played with like the dead timers and stuff like that, changing the router ID. But it was in the Encore lab manual. Where are we at here? Configure OSPF advanced features, and it comes right after the OSPF multi-area lab. So I said, let's go ahead and knock this one out, man. Again, just look in the description box of the video, and y'all can do it along with me and stuff, man. We should be able to knock this out real quick. I know it's 9 o'clock. I know, man. I know. We were right at the hour mark, but I said, let's knock this out, man. Tomorrow, I don't know. We'll probably do, I don't know. Don't get intimidated by this. We only got a little bit to do here. We got 3 routers here. Let's take a look at this topology. We got router 1, router 2, router 3, similar to the other lab. We got 4 local area. We got 3 local area networks. We got 1 here, 2 here. We got the 3rd local area network here, and then we got a wide area network here, along with the web server there, right? What do they want us to do here? I think I looked over it real quick, and I was like, oh, we should be able to knock this one out real quick. Here's the addressing guide. Again, if you want to copy this, go in the description box of this video. Y'all make sure y'all hit that like button too. Modify OSPF default settings here. In this activity, we will OSPF is already configured, so we ain't got to worry about all that. It's already have full connectivity. We will modify the default OSPF configurations by changing the hello and dead timers and adjusting the bandwidth of a link. Then you will verify full connectivity is restored. Y'all remember what the default settings are, right? Modify the default settings. Part 1. Test connectivity between all end devices. I'm not going to test all of them. We'll just do one. Verify that all PCs can ping the web server. I'm just going to have PC 1 ping the web server, and that's it. I'm not going to do all 3, right? So we can get the hell on. So I can leave y'all alone so y'all can get back to y'all studies over there. And Francisco can fuck up his home network over there so that way his kids can get mad at him or his wife can get mad at him. Ping 64.100.1.2. Get on our knees, pray to network gods, hope for a reply. You're timed out. We got a reply. Good. Remember that first one usually drops because of we haven't built an ARP cache just yet, right? Next thing they want us to do is adjust the hello and dead timers. They even showed us how to do it there, so that's why we should be able to knock this one out here. Enter the following commands in router 1. So they want us to change the hello timer to 15 seconds and the dead timer for 60 seconds to 60 seconds. Y'all know what the default is though, right? What is the default on a broadcast network? I think I've asked this a million times on this channel, but it is what it is. Francisco said I'm crying. I'm just messing with you, man. But they want us to go on the serial interface here. Enable show IP interface brief. Which one is it? Serial 000? This right here. They want us to change those timers. Let's see what they are, right? Show IP OSPF interface serial 000. Let's take a look at them first, right? On a point-to-point network, it says it's a point-to-point network. Our timers are hello 10, dead 40, wait 40, and retransmit 5, right? So we say hello, just like on a broadcast network, we say hello every 10 seconds to our neighbor. Hello, wait 10 seconds, and we say hello just to make sure that he's still alive, right? And then we consider him dead, proper words they use there, right? After 4 times the hello, not necessarily 40, but 4 times the hello. In this case, now this is default, we can change it, and that's what we're about to do. Hello every 10 seconds, and 4 times the hello is what? 40. So we consider him dead if we haven't heard from him in 40 seconds. And then the wait timer is 40, and then we retransmit in 5 seconds. We're just going to change those two to 15 and 60 respectively, right? So we go to global config mode, interface serial 000. What is the wait timer though? I don't think I really explained that correctly. What is the OSPF wait timer? Anybody want to? Peter Hunt said 10 and 40. Yep, exactly. And so did Foster. Exactly. I'm glad y'all paying attention, man. What is the wait timer though? Do we wait before we hear from an OSPF neighbor? What exactly does it do? I couldn't tell y'all. Let's see. OSPF wait timer. Let's see. It waits for 40 seconds in broadcast network. Oh, this is for the DR election. It waits for 40 seconds on the broadcast network. Default dead interval is 40 in broadcast. And then it elects itself as DR and then continues sending hello packets, specifying itself as the DR in the DR field in hello packets. So that's what the wait timer does. So we wait to see if we have any other designated routers or whatever before we consider ourselves, I guess, a BDR or a Drother, right? Does anybody, Kelvin, can you chime in and let me know if that's exactly what the wait timer is? So let's go ahead and change that, because I know somebody in here like, will you change the goddamn timers right now? Hello, we said IP, Ospf interval, or hello interval is going to be, we can do it from anywhere between 1 and 6,500 and 535. They said 15, right? And then IP Ospf, they said dead timer, change that to 60, 4 times the hello, right? 15 times 4 is 60, right? So now that we've changed that, theoretically, we should drop our neighbor, right? So we did it on interface serial 0, which is, where is that? That's over here? Yeah. So we changed the timer here. And being that these 2 timers got to match, if this was left by default, we should theoretically lose router 2 as a neighbor in 40 seconds. Cue the Deputy theme song. And there it is right there. Dead timer expired, interface down or detached. And that's why we lost this guy as a neighbor. So now we consider router 2 dead, even though he's alive. It's just that our timers don't match, right? We might have to do the same thing on router 2. What's the next thing they want us to do here? After a short period of time, the OSPF connection with router 2 will fail, which it just did. Both sides of the connection need to have the same timers for the adjacency to be maintained. Anybody remember all of the parameters that need to match for us to become neighbors other than the hello and dead timers? There's multiple OSPF parameters, right? They need to match. We say hello timers got to match. Dead timers got to match. While y'all figure that out, I'm going to go to the other side and make the hello and dead match, right? On router 2. We go to global config mode. We say interface, what is that? Serial 000? Yep, serial 000. So serial 0000. We say IP OSPF hello is 15. IP OSPF dead is 60. What else they want us to do here? We go to, so adjust the timers on router 2, which we just did. Foster said the MTU needs to match. Yep, maximum transmission unit, right? The size of the packet the maximum size of packet that we need to send, that we're going to send on a link, is considered our maximum transmission unit. They got to match between the 2 neighbors before they become neighbors. She also said the same area. We need to be in the same area, right? If I have an interface in area that says in broadcasting area 1 and yours says area 0, we ain't gonna become neighbors. We also need to have the same network area. And like Peter Hunt said, he also said authentication. If we have all the authentication set up, they got to match, right? So if I have an OSPF password, whether it's MD5 or clear text, that other guy needs to match as well. What else? Aaron Lou said Yeah, same thing. You guys are all on the ball here, man. So all those got to match. And notice our OSPF neighbor came back up. We're good to go there. We have 80% complete. See, I told y'all this was going to be quick, man. Adjust the bandwidth setting on router 1. So we need to change the bandwidth setting. Trace the path between PC1 and the web server, which is from here to there. But I don't know if he's actually going to take here or here. They want us to trace to find out. Is he going to go from here to there to the web server, or is he going to go from here to there in the web server, right? We'll find out. One of them has 2 hops, right? So 2 hops. Notice that the path from PC1, let's trace it first before I notice that, right? So we do the same thing, but we're going to say trace instead of a trace route. Do we have to actually type it all out? 64.100.1.2, or do you got to do trace RT? Yeah, trace RT 64.100.1.2, and there it is right there. Says we took 4 hops to the web server. We went from 172.16.1.1. Who's that? That is this guy right there, I believe. I believe is there. Yeah, 16.1.1 is the gig interface, so our default gateway. And then the next hop was 3.2, which is probably router 3. No, it is router 2. Yes, it is the 0.0.0. So the first hop is here. The next hop is here, right? And then after that, next hop, it'd be 209.165, 200.226, right? So that is what? That is this interface right there? No, 224. So no, it is somewhere in here. It will be 226. That's 224. So the first hop, again, is from here. Next hop will be there. The next hop will be there. And then the final hop, 61.2, will be the web server, which is there. So it took, again, from here to there to there to the web server, right? Now they said trace the path. Notice that the path from PC1 is routed through router 2. So we went through router 2 to there, right? OSPF prefers the lowest cost path, right? So that was lowest cost path in that case, I guess. On router 1, 0.0.0 interface, set the bandwidth to 64 kilobits per second. This does not change the actual port speed, only the metric that the OSPF process on router 1 will use to calculate the best routes. So we change it with that right there, bandwidth 64. I like how they just gave us the answers there, in case you don't know how to do it, right? Damn. I guess y'all can get the annoying bruh sounds again. Phone died. It's all good though. Need to get so we need to go to the serial interface and change the bandwidth on that, right? And then they want us to trace the path and see what path it takes this time, right? So we'll go to router 1, and we're going to change the bandwidth on this interface there. So we're basically going to make it worse, and it's going to say, hey, that's too slow. Let's go this way, even though it's 1, 2. It'll be more hops to go that way, basically, right? So I think it'll be, let me see, 1, 2, 3, 4, and then the 5th hop would be there. In this case, it was 1, 2, 3, 4. So now it's going to take 5 instead of 4 hops, right? Y'all with me? So we go to global config mode and make that worse. Make that path worse. Bandwidth 64, they said, right? That should theoretically say we're pretty much done with this. It was, I told you, it was a short lag, right? See, 100% complete. Now they want us to trace that path again, and notice that the path from 64.1.12 is redirected through router 3. So instead of going this way, right? Instead of going that way, we're gonna go from here to there. See that? By saying this is worse. So it's kind of like I don't know, we've seen a lot of cars and stuff that way, you know, and that's exactly how OSPF works on or the SPF algorithm works on GPSs. When it finds there's like too much traffic and stuff like that, and it finds a quicker way or whatever, it'll recalculate and go the other way. That's exactly how GPS works. So now let's do a trace route from the PC again. PC1. Last time we took 4 hops, and it should take a little bit longer this time, right? Yeah, see, notice he had 1, 2, oh, it says it right there. 4 hops there. Now it took us 5 hops there. And this time, it's pretty much the same thing, right? So 16, well, not same thing, but it took a different way. This time it took 192.168.10.6, which is this hop. This is the next hop. 1.6 says, yeah, that's the next hop. So now, instead of going that way, it took that way. That way, float on the track like a Segway. I think that's pretty much it, man. Verify all PCs can ping the web server, and we just did. We're at 100% complete. So that's pretty much it, man. Y'all fuck with your boy, man. Make sure you subscribe, hit that like button. We're gonna stream again tomorrow, 8 p.m. Eastern Standard Time, Monday through Thursday. If I do cancel, make sure you join the Discord server, and you'll get like the heads up and stuff like that. And Ashlyn said MTU is usually 1400, right? No, I believe the MTU is typically 1500. But let's see. That's a good question. I like that question. 1500 bytes, right? Let's see. What is the default MTU? Damn, I closed it already. Shit. Why did you ask? Why did I look away, man? I can't even hit my bros right now. We can Google that, man. I think the default MTU will be 1500, but that's a good question. I like that question. Default MTU for Cisco, I guess it depends on. It depends on the interface, right? 4470 bytes. No, that's ATM routers. My bad. Why is MTU 1500? Yeah, 1500 bytes. The de facto maximum standard is now unofficially set to 1500. Who is that resource by? I don't know who that's by. I never heard of this. This is some UK site. The default MTU is usually 1514, so roughly 1500 bytes. But yeah, but that's a good question. It really depends, though. It could be like 1400, and then you have some headers information that'll bring it to 1500 bytes. So it really depends. I think Zaya said 1500. Yeah, y'all correct me if I'm wrong. I mean, we could like have a little debate here, the discussion here, not necessarily the debate, but we could just kind of see configuring MTU settings. Let's take a look at this. This is a Cisco white paper right here. Default right here, information about the MTU. The default MTU sizes for frames received and sent on all switch interfaces is 1500 bytes. So, but now that's a switch now, right? 1500. Yeah, most resources, most networklessons.com. That's usually a good site. Shout out to Renee Molnar. That's his website. Yeah, typically it's 1500 bytes though, man. Peter Hunt said it's like 1472 to 1500 to 1514. Yeah, exactly. Can't remember the headers right now. Exactly. So you might have like some header information for like VPN or like IPsec tunneling and shit like that. Excuse my language, but other stuff that's tacked on that'll bring it to about 1500. Or it might go even more than that, like he said, 1514. It usually depends, but on average, it's about 1500. Notice 1500 is in the middle of those three numbers that he gave us right there. So that's pretty much all I got for y'all, man. Like, comment, subscribe to the NetworkBruh. Typically, we stream Monday through Thursday, 8 p.m. Eastern Standard Time. For now, just comment, like, subscribe.